Welcome to Bonding, the new dating agency where metals and non-metals compare and two non-metals compare with each other. It's Ella meant to be.
So what exactly happens here?
Well, we provide two services. We can find you a life partner where you will bond ionically, or a life partner where you will bond covalently.
That sounds interesting, but how do I know which one is right for me?
You don't. If you are a metal looking to bond with a non-metal, you'll have to bond ionically. Whereas if you are a non-metal looking to bond with another non-metal, you will use the covalent bonding service.
Okay, so say I was sodium and I wanted to bond with chlorine. I would have to give him one electron, and I'd be alright with that because that would mean I would have a full outer shell. But he would also really love my gift because that would mean he would have a full outer shell as well. Ionic bonding is all about giving and taking.
Exactly. If you have a look at this periodic table, you'll see group 1 metals, like sodium, are free to give away one electron, whereas group 2 metals, like calcium, are happy to give away 2 electrons.
Hold on, doesn't that cause a problem? Chlorine's only looking for 1 electron, whereas calcium's giving away 2.
That problem is easily solved, but it's an excellent question. Calcium will bond with 2 chlorine atoms. We're very broad-minded like that.
Can you tell me about covalent bonding?
Well, the main difference is that atoms don't give up or take electrons. There's no exchange of gifts. Covalent bonders are quite happy to share.
But what about the outer shells? Are they still full? Are they still happy?
Absolutely. Let me give you an example. Oxygen has 6 electrons in its outer shell, but it desperately wants 8. If it bonds with another oxygen, they can each share 2 electrons. That way, they each have 8 electrons in their outer shell, but in reality, there's a bit of sharing going on. That happened last week.
What happened?
They formed a telecoms company and lived happily ever after.
But what if you're looking for something different? I mean, it's all right for oxygen and nitrogen and bromine to keep themselves to themselves, but what if you're looking for something different?
We can still help. Last week we had a carbon come in who wanted to form a bond with oxygen. He ended up bonding with 2 oxygens. Atoms are like that. They always want more. Anyway, they formed carbon dioxide and just exhaled out the door like a belch of fresh air.
I heard that once an oxygen made off with 2 rather attractive hydrogens and it started getting very wet. Do you have any more juicy gossip?
Well, last week we had a mixer for all our new clients. There was a lot of people there. There was nitrogen, phosphorus, carbon, lots of oxygen and silicon. They all started forming into small groups, as you do, and then suddenly, boom, phosphates and sugars everywhere. Then other elements started to combine to make bases, and then the hydrogen bonds got involved, and kaboom! DNA. It was huge.
What happened next?
You tried to set up a dating agency to help atoms meet each other. You just want to help. But a giant molecule made of phosphates and sugars? We just couldn't cope. I don't know what's going to happen if it starts replicating. The whole planet could be infested with life.
Makes you think, doesn't it?
This has been a Science Rocks production.